What's going on, guys? This is the final exam review. Watch the video over and over till you understand what you need. Hopefully you pass that final.
Alright, what's up, guys? This is Unit 7 portion of the final exam review. Hey, I'm going to section this whole thing off so we can continue focusing on specific sections of each video. So, hey, that was Braylon. That was Braylon Wings. You guys know him as Bray. Awkward's introduction. All right, but let's go ahead and get started on this actual final exam review. Hey, this first part, question number 1 for Unit 7, guys. It asks us, in this function, y equals a times b of x, b raised to the power of x, what does b have to be in order for the function to be exponential decay and exponential growth? All right, if you remember way back when, to have an exponential decay, your b value had to be, and let me write it down, man, for decay. Your b value has to be greater than 0, all right, but less than 1, okay? And for your growth, your b value must be greater than 1. All right, just greater than 1. So here, you want anything larger than 1. 1, 1.1, 1.2, 1.001, 3, 4, 5, any number larger than 1. Here, it needs to be a decimal or a fraction that's smaller than 1, like 3/4, 0.67, stuff like that, smaller than 1, okay? All right, for this first part right here, it says in 1981, Australian humpback whale population was 350 and increased at a rate of 14% each year since then. Write a function and model the population growth. What was the population after 5 years? So first of all, we got to write a function that models this. So we know we started with 350. All right, and I'm going to say, we're going to call this f of x. All right, we started with 350. That's our initial value. All right, and it increases by 14%. So we're going to take that. We have 0.14. But as we just talked about, remember, to have a growth, it has to be greater than 1. So we're going to go 1 plus 0.14. All right, 1 plus 0.14 or 1.14 raised to the power of x. This will give us a growth. All right. Or you could have wrote it like this: 350 times 1 plus 0.14, and that'll give you 1.14, still raised to the power of x. It's the same function, okay? But anyway, there's our representation, and now we want to solve it for how many whales there'll be in 5 years. So again, if I solve this for alpha 5, all right, and I go 350 times 1.14 raised to the 5th power, all right, that is going to give me 673.9 or 674 whales, okay? This next problem right here. All right, this next one right here, find the inverse, guys. To find the inverse, guys, you remember that f of x is y. All right, so the first step you're going to do here to find the inverse is swap x and y. So you end up with x equals 1/3 y plus 7. All right, and the first thing we're going to do to solve this is subtract 7 on both sides. All right, so you end up with x minus 7 equal to 1/3 y. All right, but now you just need to solve this portion for y. If I multiply by 3 on both sides, like so, the 3's cancel over here, so I'm just left with 1y or y. All right, and over here, I'm going to go and distribute that to have 3x minus 21. There, guys, that's your inverse. And this just means inverse. This little symbol right here means inverse. Y equals 3x minus 21. Or the inverse of y is 3x minus 21. This is your inverse right here, guys. All right. All right, this next problem right here is an investment problem. I'm going to erase just so it's not so cluttered. This one says you invest $1,335 into an account that pays 7% interest. Calculate the total amount you have after 12 years given the following. All right, so first of all, let's write down this equation we're going to use. All right, the equation we're going to use here is A equals P times 1 plus R divided by N raised to the N times T. All right, remember that R is your rate. All right, your rate as a decimal. All right, this is your rate. N is your number of compounds. All right, and T is your time. All right, but it must be years, okay? It must be years, time in years. So this one says annual. All right, if you think about annual means once. All right, once a year. So that means annually our N is going to be 1. So when we plug everything into this equation, we have the principal times 1 plus our rate, which is 7% or 0.07. All right, we always convert our percents to a decimal. All right, so convert R to a decimal. And then our N is 1. It compounded annually, so 1. All right, and then we raise it to the N, which is 1 times time. And they told us that it's 12 years. All right, so it's 1 times 12. And guys, these equations right here, you can put straight into your calculator, all right, just as you have them presented. So when you do that, you end up here with $3,006.68. All right, so that's compounded annually. If we were to compound it monthly, all right, the difference here is now N is 12. All right, N is 12 because monthly is 12 months in a year. So our equation will still be P 1,335 times 1 plus our 7% divided by 12 now because it's 12 months in a year. And then we still raise it to N times T. So that's 12 times 12. All right, or you could write 144. 12 times 12 is 144. So you can actually raise this, guys, to 144. It's the same thing. 12 times 12 is 144. Now, when you do this, again, put it straight in your calculator as shown. You'll get $3,084.81. All right. Next, it says compounded daily. All right, daily. All right, now N is going to be 365 because there's 365 days in a year. All right, so when we do this daily, let me change colors. We have our principal amount times 1 plus 0.07 divided by 365 raised to the 365 times a year for 12 years. All right, 365 times 12. All right, and when you do that, guys, you're going to get $3,092.10. All right. So here, guys, here's all your compounded interest equations. Okay. Now, let's look at this next part. Right. Now, our video here, excuse me, not our video, our next problem 5 here. We're using this function, all right, which is represented on this graph right here, guys. We're going to answer these questions based off this graph. The first part here is, let's see here. We're going to answer the domain question. All right, I first want to show you that there's an asymptote here. All right, if y'all see how this turns and goes straight down, there's an asymptote present right here. Actually, let's use a dotted line. There's an asymptote right here. All right. Straighten that out. Now, with that asymptote being there, so with your asymptote right here, guys, this is where the graph doesn't pass that line, which is at 4. All All right, so see how it continues in the positive direction? It goes that way infinitely. We're going to say for our domain that's all real numbers or all x's greater than 4. All right, it just continues going to the right infinitely greater than 4, okay? Now for the range, this thing goes completely down. It never stops going down, and nor does it stop going up. Although it's going to the right, it's increasing subtly. All right, and it'll increase and continue to increase infinitely. All right, so the range for this and these other logs is going to be all real numbers. All right, all real numbers. All right, or some of you guys like to write negative infinity to positive infinity. That's cool too. Okay. Now the transformations. The transformations we're going to describe all come from right here. All right, this is a log function. This negative 4 here tells me it went which way. We're going to say right 4. All right, and then this minus 3 tells me it went down 3. Okay. Now the intercept, I know you can't see it here. All right, you can't see it on this graph, guys, but the actual x-intercept is 1004, 0. And the y-intercept, guys, this will never cross 4. So there is no y-intercept. Actually, we're going to put none. All right, not applicable. There's no y-intercept. For increasing and decreasing, you read this from left to right. So as I travel from left to right, following this line, all right, I'm increasing from 4 to positive infinity. All right, you got to talk about the x values. All right, from this 4 out here to positive infinity, this thing is continuously increasing. All right, and then the decrease, there's none because, again, it's going to the right. If I went this way, all right, there's no decrease. All right. Asymptote. The asymptote. Remember, we have a vertical asymptote right here at x is 4. So we're going to say x equals 4. You also know that again because it says minus 4 right here, which means right 4. So that's where the asymptote is. This applies to logs. All right. Now in behavior. As x goes to positive infinity, which means as x goes to the right, where's the function going? Remember, it's going up slowly, so we're going to say positive infinity. And as x goes to the left, all right, as it goes to the left, it approaches negative infinity. So as it's going down, we're going to say negative infinity, right? So that's problem 5. Now for 6, we have an exponential function, okay? The first thing we need to do here is graph it. We're going to actually graph this one. So you're going to put it in your calculator like so, and then, of course, hit graph. You're going to hit graph like that. And here's your graph, okay? Now, based on this equation, that minus 4 tells me where my horizontal asymptote is. 1, 2, 3, 4. That's a horizontal asymptote right here at 4. So I'm going to sketch my asymptote. There's my y-intercept. It looks like at 2. Or I'm sorry, 1, negative 1. So here we go. Let's sketch this thing. I have a horizontal asymptote at negative 4. So, and I have a y-intercept at negative 1. So my graph is going to look something like this. Alright. Now, I'm not the best freehand drawer. Alright, so that's my best sketch, okay? Anyway, domain. Alright, this will continually getting wider. This will not stop going in the left direction. So the domain, guys, is going to be all real numbers. Exponential, all exponential functions, the domain is all real numbers. That's a little hint right there for you guys. For the range, all right, however, you see how it doesn't go below this negative 4, guys? So we can say that all the function is above negative 4. So we're going to say that the range is y is greater than -4. All right, it's greater than -4. Now the transformations. Remember, this is the parent function. All right, this is what the function looks like originally. What happened was we moved it to the right, to the left 1. Plus 1 means left 1. And then we moved it down 4. All right, left 1, down 4. And now intercepts. All right, the x-intercept, guys, use your calculator for that. All right, if you don't remember, let me show you how to do it real quick. You will go, let's see here. You can go trace, second trace, because we want to find the 0 or the intercept. Now the intercept, the 0. All right, so option 2 here. And you're going to go left bound, which is on the left side of this point. See how I know it's below, but it's on the left side of that point right there. So left bound, then move your cursor to the right side. Anywhere. You can move way up here as long as it's on the right side of that point. And then hit enter a third time, and there it goes, 0.26. All right, 0. So 0.260. There's our x-intercept. Our y-intercept, we can clearly see at -1, so 0, -1. All right, and then we have increasing and decreasing. So as from left to right, all right, as I go to the right, there's my increase. So we said this thing increases from -infinity to +infinity. All right. As for a decrease, this doesn't decrease, guys, from left to right. This doesn't decrease, so not applicable. All right, there's no decrease. The asymptote, remember this is the asymptote. Now look at the values, 1, 2, 3, 4 is y is -4. All right, y is -4, we went down 4. All right, anytime you go up or down, it's y. Anytime you go left or right, it's x. Now in behavior, as x goes to the right, where is this function going? To +infinity. All right, in terms of the y value. So this is going to +infinity. And as x goes to the left, all right, as the function goes to the left, how far down is it? It's going to -4. Okay. So hopefully this clarifies number 5 and 6 for you with graphing these and using the graph to find your information. Okay. All right, this one. All right, rewrite 4 to the 5th equals 1024 as a logarithmic form. All right. Remember, this is your base, so you end up with log base 4. That's your answer, and it equals your exponent. Okay. Now here we're going to take this log and write it in exponential form. Your base is still your base, your exponent, and your answer. All right. And our last part of unit 7 video, guys. Describe the transformation. This negative out front tells me it reflects the x-axis. This +5 tells me it went left 5. And this +4 means up 4. All right. Now, this right here concludes Unit 7 video. All right, it's about 19 to 20 minutes. Hey, make sure you tune back in for the next video, which will cover Unit 8. All right.